Okay, so this question gives us some information that we don't really need. So it tells us how much nickel, the impure nickel that we started with, how much of the gas we obtained, and then how much of the carbon monoxide gas that we started with. Now, if we have this balanced equation and we're interested in finding out how much nickel was formed, then we can kind of work backwards. So another hidden piece of information that it gives us is that we're at standard conditions. So at standard conditions, temperature is equal to 0 Celsius and pressure is equal to 1 atmosphere. Now 0 Celsius is also equal to 273.15 Kelvin. Another way to remember this is that at standard conditions, the volume of a gas is going to be 22.4 liters for every 1 mole. Now, this is only at standard conditions, so if your conditions change, you'll have to use the ideal gas law. So if we take this 6.25 liters of the nickel carbon monoxide gas, we will take 6.25 liters, and then we'll divide it by 22.4. And so this gives us the moles of our complex, which, since the coefficient here is 1, and the coefficient here is 1 as well, then the number of moles of the nickel carbon monoxide is going to be equal to the number of moles of nickel. And so in this case, I'm getting 0.279 moles of nickel. Now it's asking us for the percentage. So if we take this 0.279 moles of nickel and we multiply it by the molar mass, which would be 58.7 grams per mole, we get 16.38 grams of nickel. Now, converting that into the percentage of nickel in our sample, we know that we had a 17-gram sample, so we'll say 16.38 grams of nickel in the 17.0 gram sample, multiply it by 100 to get it as a percentage, and we get 96.3%. And that should be the correct significant figures as well, since we have 3 significant figures here and also here.